Hey everybody, welcome to the Unreal Engine livestream. I'm Alexander Pascal, and joining me today, Max and Alan. We're going to be talking about McLaren stuff in just a little bit, but first, we've got the news. Shelly, let's do this.
That
All
almost
right, cool.
sounded
There it goes.
practiced.
Yeah, I kind of say that a lot.
Like we
actually.
had that rehearsed.
Yeah, we spent an hour rehearsing that one line. That's how very talented I am at remembering my lines. Right, so 412 Preview 2 was released for early adopters. As you know, as we roll out each new preview, we're rolling out more and more fixes, and we're taking in more of your feedback. So try Preview 2, let us know what you think of it. Check out the full known issues and forum posts. Stephen Ellis, of course, is posting these great, here I'll just go to it, great forum post that has a full list of the exact specifications of exactly what got fixed. Yeah, so this is the full list. There you go, Preview 2, massive list of fixes. Again, this is huge. 412 is shaping up to be one of the bigger builds that we've got. It's going to be pretty impressive when the whole thing gets out there. So that's that and that. All right. There's been an Unreal Engine Marketplace update for April, which happened a few days ago. But again, thank you to Marketplace team. Thank you to everybody who put something out on the Marketplace. We have some pretty impressive things to show off. Great new assets, great new packs. It's a ton. This was a pretty big push, it looks like. And also, I believe this is the one where I get to say that we have, yes, code plugins. That's right, you've been asking for them. Here they are, code plugins. The first 3 showed up. They're working, they're good, they're awesome. Go check them out. And if you've been working on a code plugin and want to submit it to the Marketplace, we are accepting those all the time now. So good work to Marketplace team, and thank you to all of our sellers. Next up, a reminder that the May UE4 Jam is coming up. We will be announcing the theme on the 12th stream, which is next week. So that'll be pretty exciting. And what else is going on? Oh yeah, we might have some new prizes for this one. I got word that we've got a couple new things coming in, so stay tuned and stay watching the page as I make some updates to it. There might be a few new shiny new things to show off, but as usual, our prizes are of course AIPD keys. It's a great game. Houdini licenses for all the winners, and we'll be raffling off 4 Intel 750 series SSD hard drives. They're fantastic. So make sure you go ahead and pre-register. Send me a PM with your team's info. I only got a couple in so far, so we're ready to start filling out the submission form. Next up, Enterprise. We talked about Enterprise a couple streams back. Got to have Simon and his team on here and discuss exactly what they're going to be doing. But we've now added in a whole new section to the FAQ, so you can go and check all the facts out. See everything that we have to say about it. It really just clarifies exactly what it is, what it'll be doing for you. We got a lot of kind of similar questions afterwards about is it a new engine type, or is it some kind of new payment plan, etc. And how it's, we just wanted to clarify how it's a service and it's not a new engine, and it's going to be there to benefit you, and you can kind of opt into it or not even bother with it. But it's for people who are making non-game applications in Unreal. So if you're making something like that, go for it. It'll be, when this actually goes up, go for it and send us your information in. But soon enough, Enterprise will be available for everybody. Cool. All right, now, next up we've got Community Spotlight. So Shelly, before we get into the actual Community Spotlight, I have to talk about people who are Answer Up top karma earners. So it looks like we have Victor Burgos, good work. I actually got to meet Victor at ECGC, so nice job, buddy. Shadow River, of course, one of our regulars is in there. And Inverted Joy. So congratulations. I know those are definitely... Thank you, Chance. Chance is actively updating this and giving me little things as I'm trying to read it. Thank you, Chance. He's updating the doc. Cool. So good work to all of you. Badges, high fives all around. Thank you to everybody who tried. Thank you to everyone who goes onto the Answer Hub and talks to each other and tries to help work out different issues. So good work to all those that didn't quite make it. Better luck next time. So, all right. So next on the Community Spotlight, back to the screen. Awesome. So first up, we have the Tron. Oh yeah, Tron. Right. So FMJ Games won the Seattle, won a couple categories of the Seattle VR Hackathon with their Tron title. This is a pretty good job kind of thing. You know, like I'm just very impressed with the title, with how awesome it looks and how much fun it was. Let's see, I got a couple of screenshots. I'll blow them up real big. Bam! As you can see, it looks a lot like the default. What do we call him? Like the default gray guy. I feel like he has a name like Tim Plate or something. And
oh, you mean our default robot?
yeah, like I feel like we had like a name for him.
He's just character, right?
He's just character. I've been calling him Tim Plate, you know. But yeah, he kind of glossed him up, fancied him up, and gave it this very cool Tron aesthetic. And yeah, this is a really cool little like VR game, very neat. Of course, Tron inspired. So good work, awesome job to FMJ. Next, okay, so another team to point out here. Sorry, I keep losing my notes. Another game to talk about, Aya Blaze. I believe I've said that name correct, but if you check out their dev blog, Aya Blaze has been, the team for it has been making a continuous ongoing blog as far as their development goes. And of course, I love these. If you're doing dev blogs, please send them to me and let me know. This is a really good one. Lots of details, lots of sketch drawings on top of actual development work, so you can see where they're going with stuff. I've been trying to kind of keep up and follow with it too ever since they sent it to me. So I highly recommend it if you're into checking out dev blogs and learning from other developers, just from like, watching what they do. Very fascinating read. So good work, Aya Blaze. And this is actually, yeah, this is only a couple in. They have some newer ones too. So good work to them. Alrighty. Next up, I'd like to say everybody should check out these. So Three Prong Gaming sent me these tutorials, and I think everyone who's making an RTS needs to take a minute to check out RTS tutorials that come out, because you never know what kind of amazing new thing you're going to learn. But Three Prong Gaming has written out a giant tutorial series. It's pretty extensive here by comparison to most others, covering everything from AI on your NPCs to the AI unemployment. So you've got unemployed AI wandering around looking for jobs. There's a lot of concepts in here that you're going to need for your RTS, whether you're doing one kind or another. That's what I found so fascinating about it. It's not really for just Command and Conquer style or whichever kind of style game. It's got a big spectrum of stuff you can learn. So to Three Prong, thank you for sending me over your playlist and your channel. And if anyone else out there has a really cool tutorial series playlist like this, send them right over, because I love to see this kind of stuff and get to show it off. Speaking of getting to show off really cool and amazing things, oh, nice transition, Shelly. I love that one. Yes. Speaking of getting to show off really great, new and exciting things, today we have Max and Alan, who are going to be talking to us about what they've done on this McLaren demo that we've shown in a couple of places. We have videos that we've posted up on YouTube. But yeah, we've got some editor stuff to show off, some actual like in-app stuff to show off, and we have a great big iPad Pro here that we can actually show some of the kind of cool applications off on. So yeah, let me grab this up.
That's the editor. Go ahead and grab the.
You want this?
Yeah, launch the full build first.
All right, let's launch this full build. I'll bring this right over here. Now going ahead and warm that thing up.
Yep. I guess go ahead and minimize the editor. Just.
The password. It's very good password. The same thing as I keep on my luggage. There we go.
Too much.
The password isn't luggage, is it?
No. They'll all know what our top secret password is. Oop. All right, let me stop trying to use my laptop keyboard and actually use the proper keyboard. So what we're seeing here is actually the real-time demonstration. You guys want to show this off?
Drive, or you want to drive?
Well, it's up to you. You can drive it. You probably know better than I do.
Hang on now. Wait. He has to drive.
That's okay. I can move it if I don't want to.
Poor Shelly.
I'll drive.
All right. So Shelly's going to focus in on the app, and I'll talk a bit about how this is actually laid out.
I'm sorry, Shelly.
We're making Shelly work hard today.
We had pre-set this up so Max would be the one showing it off.
So here we have the interaction controls. This is actually where you swipe to do camera motions. If I did it now, it'll actually break out of the cinematic, and the car will drive in. And that's what the indicator for swipe is here. We've got some other controls for zooming in, doing some other special functions as well. And then below that, we've got the category listing, and these are configuration options that you can change on the car. So for example, and I can't really see very well here, I can change between carbon fiber and body color for the mirror casings. So every time I touch one of these, it changes on the car. Now, this is on our network here, and the engine is getting messages from this. And Max will talk quite a lot more about that in a minute. But it's all very easily configured. So then we also have these interaction points, the little hands that you can see. And just a tap on the screen while over one will cause that to happen. So I can go over here and open up the door, the window comes down, door opens, and I can look around. So all of this was done kind of incrementally. We decided what we wanted to do on the car. Later on, we decided how we wanted to interact with that and present it to an audience. And that's when we decided we should do something that's a little more intuitive than giving somebody a gamepad controller and say, well, the X button is mapped to this, use the bumpers for that. So Max came on and did a lot of the underpinnings for the app to allow us to do that. And then it was a lot of blueprint work to take the data that the app is sending to us and translate that into something that allows for camera input, allows for changing things like configuration options and things like that. So a few of the other things you can do now that I'm able to actually see the screen. As you change configuration options like the paint, let's go with one of my favorites, Fire Black. There's just a hint of red in there, or even bourbon, which has got a nice kind of deep brown. As these options change, normally if you're going to buy a car, you want to set it up the way you want, and then we can go into our configuration viewer, and it will run a kind of a modified version of the cinematic that it runs on start to show you all of the options that you've changed. And then any further change to that will break out, and now I'm changing the interior colors. And I can actually go inside the car, open it up, and this will unlock an interior interaction, which will actually take me into the car, and I can look around. And since I'm sitting in the driver's seat, it's actually going to start up the car. You'll see the whole HUD information system in the car activate, and I, of course, can still continue changing options. So I'm going to go with the carbon black McLaren orange interior. I can look around. You can see we've got a nice Alcantara dashboard, so it's like a soft suede. And at any point, I can tap and be right back outside and see the entire car. So I'm going to drop down to the editor now and talk a bit about how we did the camera controls and how the blueprints were set up to interact with the car, so the blueprints could talk to each other, and we could get all of this kind of working as a seamless whole.
Shaders look so good. I think McLaren actually sent us some samples of all the
So
surfaces.
McLaren has this whole configuration kit of kind of simplified body style of the car in all of the different paint colors that you can choose. So you can see an actual real world sample. There's the mantis green. And then they also have these kind of plates with the leather or other fabrics on them. So you could actually pick up all of these different materials and put them together and see, okay, my car is going to be ice silver with Alcantara dashboard, carbon black seats, mantis green stitching. And obviously, when you buy a car like this, you can go through and choose these, and then they'll either deliver it or build it and send it to you. Go ahead and exit, break away from that. So here's the exact same scene in the editor, and you can see there's a number of cameras placed around, and these are the interaction points. When you pick a configuration option, like if you want to change the wheels or something like that, I know based on that camera's position where I want the primary camera to be. So that's what you're seeing there. So here's the car itself, and the car is this rather complex P13 blueprint. So the way it's set up is the car handles doing everything that the car would do, changing its paint color, setting wheels, and things like that. You can see there's a number of different graphs, but if I go into my event graph, you can see I've got all of these different things like swapping the roof, swapping the spoiler materials, and things like that. So whenever I get a message from the app, what I'm doing is I'm filtering for what category and what index it is. So like I'm changing the spoiler from carbon fiber to the black, I can't remember the name of the other material, but there's two materials for that. What we're actually doing is I'm getting this event sent to me that says, you're changing this, in this case the spoiler, and here's the new index. That index then looks into what's called a data table. And this data table, which you can see here, is essentially all of the different categories. You can see paint, wheels, brakes, calipers, and so on. And there's a few that we don't actually use for this, but inside of that, it breaks out into multiple structs that have what the different options are. So, for example, if I get this category of wheel and then I get index 1, that means it's going to get the super lightweight forged wheel. And then knowing that, can then change the mesh and or material on the car itself. And that's where this comes in. So I get the data table that I want to work with. I break it out. I get the individual index that I want. So I know that I'm getting the wheel or in this case the spoiler. I'm going to get from the data table, and this is actually going to tell me what material to apply. So I get that material, and then I apply it to that part of the car. The car in this case is really pretty complicated in terms of the number of parts, because the car has quite a large amount of the interior structure of the car. You can see the entire engine in here. All of this is rendering pretty much all the time. So when you're seeing the car move around, all of this stuff can be configured. We can explode the car out and do all sorts of cool stuff with it. But that also means that we need to know specifically which part of the car has which material and know when we can change that. So that's what all of the behavior in the event graph is doing. So here's all of those different swaps. So side ducts, rear bumper, so on and so forth. The most complicated one by far, the most complicated two are the paint swaps, which happens here. So because you have cases where, say, you're changing the paint color, but the roof is set to carbon fiber, it's not going to change. We need to make sure that we know what state the roof is in and only change it if it's supposed to be body colored and things like that. We also play sounds, so there's a whoosh that happens when the paint changes. And then here, I've got an array of all of the different parts of the car, and I'm going through and doing here it is. So I'm doing a for each of the array of body pieces and painting them, basically. So every time you pick one, it says, oh, you want all of these pieces to simultaneously get the new material and apply it. So the data table has all of the paint materials. Show that here. So here's the paint. You see it's got the name, so Blade Silver, and then it's got the icon that shows up in the app, and then also the paint that will be applied. So I'm basically just harvesting from this, saying, oh, you want paint number 3. Paint number 3 is Blade Silver, or, well, actually 3 would be the Mantis Green. So here's the material I want to apply. Here's the icon that's going to show up in the app. And what this allows us to do is really quickly change how both the app and the configurator perform. So if we decided we didn't want them in that order, which we actually did at one point. We changed the order that the paints appeared. It's really easy to do that without having to go in and change a bunch of blueprint behavior. All I care about is that number 3 is getting set, and then the contents of this data table can be rearranged at will, and that will show up in both the companion app and the configurator. So back in the car, there's a couple other things that are going on. So the very first thing I was brought on to do was actually the orbit camera. And if you go into the blueprint folder for the car, which is probably easier to just find it. So I have an orbit state blueprint that is basically just, here's the origin of the blueprint, and then you notice there's 2 vector parameters, position 1 and position 2. What we wanted was, as the camera goes around the car, to try and frame the car at all times so that it's never quite out of frame in the front or back. Well, cars aren't round, so we had to basically move the center of the camera to the front and the back of the car as the orbit. So instead of a circular orbit, you get an ellipse, kind of trying to keep the car equidistant from the camera at all times. So the easiest way to do that was having 2 positions, 1 and 2, with an exposed widget, so I could kind of tweak the positions, select it, and move it around a bit if I wanted. And then inside my navigation handling blueprint, I'm just driving a timeline that's moving this camera around. So I have a timeline that says, here's the curvature of the position around the car, and then here I'm receiving a position that's being sent in by another blueprint, and that drives my timeline point. So I can author this completely separately from everything else. If somebody's working on the navigation blueprint, I don't have to block them if I'm making changes to the orbit camera. So speaking of the navigation blueprint, I have this navigator blueprint, and this is what handles all of the movement around the car. There. It also handles sending messages to the interaction points as it detects them. And so, like for example, when you move the camera, all I'm doing is I'm tracing straight out from the camera, seeing if I overlap one of my interaction points, and if I am, that's the one that'll interact when I get a tap from the controller. So it's very dynamic. If I added 5 more interaction points, as long as the camera overlaps them, they're triggerable. All I have to know is, what do I do? So each there's an enum for which interaction points that exists, and then I can just go and filter based on that, which actually happens inside of the interaction point itself. But here we have things like the camera control. So zooming in, here we have begin play, which actually sets the state of the camera. And then here's the most important part. This is what's happening on tick. So I've got pitch and orbit position handling. So this looks a little complicated. Essentially what I'm doing is I'm receiving the input from the app as a position, and then I'm driving that. So here's touch pitch, touch rotation. Those then get filtered to be in a nice clean range and also eased, and then it just sets these as the new camera pitch and yaw. And then every tick, this is getting updated so that my camera motions are being eased, my rotation is being set, and then position is being sent to that orbit state that you saw before. So I actually have my orbit state blueprint referenced here. So I'm actually getting my orbit state, I think, yeah. So I've got my orbit state, which is being defined on play. So I know once the blueprint starts going, it finds any orbit state, it sets that as a variable so that I can then just call functions on it directly. So the blueprint communication going on is really straightforward, rather than having a blueprint interface where I send the message and then I filter for getting the correct message and making sure I do a cast to find out what it is. I just call it on the orbit state. So you can see here, I can just do set position, and there's that variable that I used to define in my timeline. Whatever I set in here, it will just move the camera in the world. So it makes for a nice, clean way of having one blueprint defining the state of things and the other blueprint executing based on those results. And you'll see that I actually do that quite a lot. I know what orbit state is in my world, what camera is being viewed from at any time, the current car itself. So this is the navigator, not the car blueprint. But there's a lot of things that I want to call on the car, like telling the car it's time to open the doors or things like that. And again, that I do just by dragging in the current car, and then I can see what functions I can call on that blueprint. So there's all of the different activate behaviors, changing paint color. So I can actually do anything that the app can do. I can just call as a function, and as long as I provide the right data, it will work. But we've also got, for the car, going to the blueprints, there's the interaction points. And this is the one blueprint that's instantiated quite a few times. I set this up to be kind of flexible. So here's that enum I was talking about. I have which interaction point it is. It has a list of different ones that I have defined already. You could expand this pretty easily. And then there's a switch based on which one I tell it is. So if it's the cockpit or a door or whatever, I then call the appropriate function. So I make sure that everything's ready to go, and then I activate the headlights or activate one of the doors. And then after a short delay, I make sure that anything, I have this concept of a linked interaction. And this is how the interior of the car works. If the passenger door opens, then I need to activate the interaction point for inside the passenger seat. Mm-hmm. So that's what this is. I have a linked interaction. It's an array, so if I have more than one, and I did that, at one point we were going to allow you to actually turn on the interior, but that's not actually the way McLaren works. When you get in the car, it just turns on the interior because it knows that the key fob is inside the car and the car is ready to go. So to look more like the actual car's behavior, we have the heads-up display and everything come on as soon as you sit down in the car. Mm-hmm. So yeah, once these were kind of driven or set up, and then each one of these is an interaction point with its own camera. You can see this is the point in space that icon is going to appear. Mm-hmm. And then the sphere that you can just barely see here, that's the radius for the camera's overlap. So if the orbit camera is here, looking roughly here, it's intersecting this sphere, and so that interaction point could become active.
Okay, that's cool.
So that eventually, once I had the orbit camera working, we realized we were going to want to have kind of that simple, straightforward interaction of, I'm looking at this thing and I want to touch it and do it. We started playing around with different control schemes using a gamepad. That was getting way too complicated for the number of things we wanted to interact with. So we started looking at maybe using something like an iPad. And so we also realized that we were going to have all these different options, and that's where the complexity came from. So that's where we started talking to Max about doing the messaging system.
Yeah, the communication part. But I'm curious about one more thing. Mm-hmm. How did you guys do the explosion?
So the exploding car.
Yeah, we should show them the exploding car. Actually, we've had quite a few requests for explode the car.
Okay, all right. I'll explode the car. It'll take a second to relaunch.
Yeah, make sure to drag that onto this menu. All right.
I'm working on it. So
yeah, actually
there's a couple of different animations that Jeremy Ernst actually authored for us. The doors opening, the bonnet or the hood opening, and then there's this tiny little oil cap on the back. All right, so if you move. So let the car roll in. One of the things that we actually had like a reveal that stripped away the skin and the material.
Boom.
So Jeremy authored this animation giving it a lot more weight. So as the panels come away from the car, it actually rides up on its suspension and bounces down a bit when the panels are back on. So we're conceptually removing the weight of the panels. You saw the number of parts that are on the car. So there's actually a skeleton that these parts are just rigidly weighted to. So rather than having a skeletal mesh that is the car doors, that is all the body panels, there's a skeletal mesh that has nothing but bones, basically. And then inside of the blueprint, they're attached. The body panels, the doors and things are just rigidly attached to those bones. Mm-hmm. There is some soft weighting for the doors for the hoses that connect, but most of the car is just rigid objects attached to bones.
Wow.
So when the animation plays, it moves the pieces the same way.
Cool. Let's check out the Oh, make it hot pink, by the way. That was another request. We have a...
We do not have pink now.
What?
There's like a volcano orange.
Not even close. Oh, I'm sorry, you guys. We don't have hot pink.
I mean, I could make it hot pink in the editor really easily.
I mean, yeah, I could. It'd be pretty easy to pick up the colors.
One of the things that we did was we worked a lot on the car paint shader. Car paint is a really complex surface because of the way they layer on multiple styles of paint. You have your kind of base color, you have your flake, and then multiple layers of clear coat that give different reflection values as the light goes through the car paint. So it's complicated to simulate. And yes, we have the kite. Francois was kind enough to stick it in there. So if you buy a McLaren, you have enough room for at least one kite. So there was a lot of iteration done on the material for the car itself. And then once we got the samples from McLaren showing us here's what these colors look like under different lighting conditions, we were able to take a lot of reference photos of these, color correct them, and then use that in material instances. So there's actually a single car paint shader with 13, I think, different material instances, which allow you to define the color of the car paint, how metallic or how strong the metal flake is, the scaling of the metal flake, the color of the metal flake, things like that. So all of that kind of builds up into being able to match these.
Get in the seat. Get in the seat. Rotate around. There it is.
Is there a way to show the engine close up as well?
Well, you can back out. Just tap. Explode the car. And then zoom.
Oh yeah.
No, there's a yeah.
There you go. So we can.
So this is as close as you can get.
Mm-hmm.
That's nice. Wow.
That's a lot of detail.
Mm-hmm.
What's that one panel that flips up in the back there? I saw.
The oil hatch.
Is that an
That's
oil
so you can
hatch?
change the oil.
Okay, well, like that.
So
once you said what it was, I knew what it did.
Yeah, the McLaren, the way it's constructed, it's not you can't easily get to the engine without like putting the car in a service bay. So they expose some of the kind of user serviceable things in a different way.
Okay, very cool.
And the other thing that I thought was kind of funny, I spent a lot of time pondering how we were going to reset the car, because especially for a trade show like GDC, you want to be able to present the user experience to somebody in a fresh way, right? I'm done playing around with it, somebody else walks up, I don't want to be in this confusing state where they've changed a bunch of things and the car doesn't look like the car. So we actually had a car in our booth at GDC. We had a real McLaren. So we got the details on what paint color, what the interior was like, and things like that, and we set those as the default for our car in the configurator. So I was wondering, like, just worrying about how we were going to reset it. I could conceivably have an array that is all of the default values, and then I call all of the settings on each part, set the wheels back, set the spoiler, the diffuser, the aero blades in the front, all of this. Turns out, if I may, just calling reset level works just fine. It's basically just relaunching the engine without actually transitioning to anything. It just reloads everything from scratch, which conveniently sets all of the variables back to their defaults and starts the opening cinematic back to where it was. So it was a really kind of nice, fast win rather than going through this complicated behavior of resetting it.
Nice. It seems like it's a lot better than having to manually.
Yeah,
change
I actually,
back every
if you
single
look in the
object.
blueprint, there's actually, you can find like there's this place of this whole reset behavior with one link broken because I didn't need it. So it just calls the console command restart level instead.
Perfect.
It worked great, but
That's
it was
amazing.
definitely a, let me just try this. I was worried that it would work fine in the editor because the editor actually handles the state of the level differently than.
The package build.
Yeah, it turned out it works just fine in a package build, and
Oh.
it was a very nice win.
That's really great. Yeah, I actually found out. I've been learning so much about this demo over time too, like things like that, like lots of neat little tricks. And I found that we have so many almost like little Easter egg kind of things hidden in there. I was talking to Tim Hobson earlier, who was helping me set up the demo for the stream, and he told me if you look on the console, like in the dash, the numbers for like the mileage and the trip miles.
Mhm.
The mileage is how far it was from here to San Francisco where we first showed it off, and then the miles for like the next trip or whatever it is. It's actually the date that they started working here was what they had put in. It was like 4/21/14. So I
There's
thought that was really
also
clever.
if you sit and watch, the info center comes up, the infotainment. The time was correct, but only once it was in Los Angeles or in San Francisco. So it actually queries the time to find out like what to set the clock to on, but it was permanently set to the West Coast. So it's always in Pacific time. So the guy who did it kept getting complaints that the time was not correct. It's like, it will be. Once we're at the show, it will be fine. But,
Oh wow. Yeah, it's amazing how many little details were kind of put in.
and things like the kite being in I think Francois may have done that at GDC.
Really?
He either did it like the night before he left or did it on the show floor because it was a very last minute thing.
It's pretty amazing how quickly this all came together.
Yeah.
And we only had like 2 months or something.
Really?
And a lot of it was, we originally were doing it on a different McLaren, and then once it's like everything settled out, it's like, okay, here's what we're doing. We had to do, or especially Min and Francois had to do a lot of getting the reference models from McLaren and importing them and getting them into the right configuration so that the engine could use it. And there was a lot of things that like Min and I had to go back and forth on to make sure that setting the paint colors would be easy, right? That one piece, like Min was excellent about making sure that for every piece that has body paint, that is element 0 in the mesh. Because when you're dealing with 30 meshes or something that each have body paint on them, you have to go in and special case anything that doesn't fit the paradigm. And for a while, it was every piece I'd have to go and write down on a slip of paper, okay, this body piece has paint in element 4, and the kind of the last round of imports and getting the interactions finalized, Min was wonderful about going through and making sure they were all 0. So it got much easier to just throw all of them in a single array and then call set material on each one in element 0, and it just worked.
Wow. Yeah, that sounds really amazing.
The exterior paint was like that. The interior paint is actually not the interior paint. The interior color styling for the leather and things like that was a bit more of a pain because like setting the stitches, it's not one piece. Right? There's the seats. There's each individual seat. There's stitching on the body or on the door. There's stitching on the dash. There's stitching on the steering wheel. There's like just all these different elements that couldn't really be shared. And unlike the outside of the car where there were at most usually 2 materials, some of the interior pieces have 6, 8, 10, 15, depending on what it is, right? Because it's got leather, it's got metal, it's got rubber, it's got different materials. So there's this huge array of set material on these 3 pieces, this one, 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 and then making sure it's the right leather color, it's the right stitch color, it's the right that got much more complicated.
Oh my gosh, yeah. So it was pretty good that you had Min to back you up there.
Yeah, Min spent a lot of time hearing me go, Min, this needs to be, because it would be, I'd find that two materials get combined into one, but in only one version of the interior layout did it need to be separate. So it's like I'm going through and I'm implementing, okay, here's this interior style, here's this interior style, and going through McLaren's configurator app online and going, okay, it's got this stitching, it's got this leather color, it's got this trim, and then you reach the special case where in only one case the steering wheel stitching doesn't match on two pieces of the steering wheel, and getting Min to go and separate those, re-import the whole steering wheel mesh, and yeah, so that was
tons
fun.
of little details.
Yeah, and it's like you don't realize where the special cases are until you're kind of deep in it and going, okay, I've got this all working except for that one. All right, go back, figure out which one piece isn't working. Matter of fact, I think Min fixed one last stitching the night before we had to be completely finished because there was oh, wow. when you have the mantis green interior, the stitching on one of the doors wasn't right. And nobody noticed until like the last day or something. So,
wow.
Yeah, there's especially when you have an object of whether it's a car or something else, when it's this complicated and this engineered so cleanly, when you get things wrong, you will notice pretty quickly. You know? And you know, we had all sorts of things where the car did really strange things, where like the animations were set to additive, so they'd blow off and then blow off and then blow off. The car went all wonky. And, yep.
Oh wow. So you said it took you about 2 months to do all this. How
Something
many?
like that.
Yeah. How many people were on the team for this? Do you know?
Most of it, 3.
What?
Yeah, it was me, Min, and Francois for a lot of the kind of building up.
Oh, okay.
Max came on. You
For the
had,
app.
what? Oh, 2 weeks.
It was pretty much last minute.
Yeah.
It was like during the last week.
Yeah.
We did have a few weeks to build the configurator itself, but
Yeah.
Because
you got the messaging system working, and then we got the configurator app working, and then you did a little bit more work after that, right?
Yeah, I think the decision to build the app was pretty much last minute.
Yeah, it was. It really was. It's like McLaren required us to have as many of the configuration options as we could get in. Well, that's on a single gamepad controller. It wasn't that it wasn't possible. It was just that it was very difficult to tell people. Well, you need to do this, and there's no heads-up display. We wanted to have as clean a presentation to the viewer as possible. So the app was really the only way that we could have that level of interaction and kind of pack that much information into a single screen.
Mm. Yeah, I think the app was mostly built by Osman in the UK.
Yeah, Osman and Alan Noon. Alan did a lot of the icons and stuff. And Osman did I'd say 99% of the heavy lifting for building the app itself. There was some back and forth on making sure the data that the app was sending was that I understood how it was coming in to me, so that I could filter it so that the camera felt good and stuff like that. But yeah, it was definitely. And the fun part is Osman is in the UK. So the time difference made it like I'm getting in and Osman is on his way out, and trying to coordinate what changes have gone in and where the data table has changed and what data I'm needing and when he can get it in and stuff like that. So yeah, that was definitely fun.
The good thing though was with my work schedule, I just got to check in the code and Osman was ready to get started in the UK.
And then you're like, hey, okay.
Yeah, because the companion app was developed so late, we had a problem with the different engine versions because the configurator itself, I think, was built in Unreal 4.8 or 4.9. For the companion app, we needed some features that were only available in 4.11, I think, 4.10 and 4.11. So the app and the configurator were not network compatible. Under normal circumstances, the communication part between the app and the configurator we would just have done using existing Unreal network replication that's in the game. But in this case, that didn't work because we had two different engine versions and they wouldn't communicate. So the question was, how do we make it work? And the quick answer is that we used a system called the Unreal Message Bus, which is a communication framework to exchange any kind of data between different processes that can run on the same computer or on different machines. And I haven't really talked about this very much yet, although we've had it for almost 4 years now. But there's still some features missing, and there are some subtle issues that I didn't quite feel ready yet to really, make it public and update the documentation and tell everyone about it. But this might be a good opportunity to go over it briefly.
Yeah, you have your PowerPoints and everything ready. So
yeah, we had a bunch of people on the forums that were interested in how this works under the hood.
Oh yeah, so you might want to quit out of that right there. There we go.
So normally, like I said, we would have done this.
Then hit F5.
See, F5.
There you go.
Normally we would have done this using just network replication, but that was not an option this time. So traditionally, the second choice would be to find some clever programmer who knows how to write network code and figure out some custom solution to have these two apps communicate with each other. That's pretty much what we've done for many years on Unreal Engine 3. And if you work with that older version of the engine, you will know that there were several tools that were kind of distributed in the sense that they communicated with each other. Swarm, for example, is one such tool that used network communication. And depending on who worked on the tool, we would be using some different kind of technology to transport the data from A to B. It could be UDP packets or TCP packets, or an HTTP connection, or a SQL Server database. We used .NET remoting and Windows Communication Foundation. Any technology, you name it, chances are that we've probably used it somewhere. And the problem with that is that it's a lot of stuff to maintain. There's not one single person in the building that really masters all these different technologies. It's a lot of code, a lot of duplication. As a programmer, I don't really want to think about how my data gets from one application to another. What I want to focus on in my application is to solve the problem at hand. How can I use the iPad to push some buttons and change the color in the configurator? I don't want to be worrying about things like network sockets and all these low-level details. And it's also difficult for the end user because they too need to become familiar to some extent with the technologies. If you're using network sockets, then you got to have some option screen where people can configure IP addresses and port numbers. It's all very cumbersome because many users don't even know what that means and what are the right values to put into that. So early on during Unreal Engine 4 development, I was trying to unify all these different solutions for writing distributed applications. And the solution for that is what I call the Unreal Message Bus. And one of the main goals was to have that system work just on its own. It just works. It's kind of like Apple Bonjour, for example. If you have an iPad on the network, the Apple software like iTunes, it will just find things and things just work. There's never anything that I have to configure. I don't have to enter IP addresses and port numbers and any of those technicalities. So I try to get that same kind of feeling. Provide the programmer with some mechanism to transport data from A to B without having to worry about how it gets there, and without having the user to configure any specifics that are related to those transport details. So if you look at the slide here real quick, I'm trying to show what the message bus is. So it's really just a framework for exchanging data. A message in our system is really nothing else but a regular ustruct. If you've programmed in Unreal, you know ustructs very well. It's our way to mark up regular C++ structures, so they become a little more powerful. You can introspect them at runtime. They can be automatically serialized and deserialized and saved in packages and so So the message bus is able to send data inside ustructs from what is called an endpoint to like another endpoint. Endpoints are parts of code that are available to exchange data on the message bus. I briefly show here on the bottom how simple it is to declare a message type. And the code for sending and receiving messages is also pretty straightforward. First, you have to create an endpoint in your software. In the case of the McLaren demo, we had an endpoint on the iPad app and another endpoint on the configurator side. And this is a very simple use case in which the one endpoint is only sending data and the other endpoint is only receiving data. There was no bidirectional communication in this particular demo, although it would be very easy to do that as well. Now, messaging systems, if you're not familiar with that, they generally split into two separate paradigms. There's publish, subscribe, and request, response. And the Unreal Message Bus supports both of those. The publish, subscribe paradigm is a way to send a particular type of message to anybody who is subscribed to that particular type of message. That allows for exchanging data with other endpoints without knowing how to actually reach them. Like I said in the beginning, I wanted to make this really simple and things should just work. So the iPad companion app that we wrote, for example, it will in regular intervals publish a message and ask, hey, who is out there that can provide a service for remote controlling a virtual McLaren car? And then the configurator side will reply, I can. And there's some handshake where they will then, from then on, just communicate with each other. In particular, the companion app will just keep sending data to the configurator application. So that's one way of doing things. And the second paradigm, request response, allows you to send messages directly to a particular endpoint that you already know, because eventually you don't want to be publishing messages to the entire world. They would really be received and processed by anyone on the network. Once you've found the configurator application that you want to interact with, you can then, from that point on, send messages directly to that receiver endpoint without having to publish the message to everybody. Now, everything I've mentioned so far about the message bus is like an in-process communication infrastructure, meaning that so far all the endpoints are located within the same Unreal Engine process. In our GDC demo, there were actually two processes. One was running on the iPad and one was running on a PC, two completely separate computers. So there is a messaging mechanism in the Unreal Message Bus called message bridges that allows for bridging two separate message buses in two separate processes or even computers over the network or some other transport mechanism. It could be UDP sockets or TCP sockets or HTTP. If you're familiar with existing message bus frameworks like RabbitMQ or Zero Message Queue, those could also be used as transport mechanisms. And you see that the code that we used to write over and over again to implement these low-level details is now hidden away in these transport mechanisms. Right now, we only implemented one that's using UDP sockets. I hope to write some other ones in the future. And perhaps the community will help us well adding some more transport plugins. And once you have that, you can actually create really interesting things. It's not just for sending messages between two instances of the game, but you can also integrate this, for example, into a Maya or 3D Studio Max plugin. One thing that we really want to do is integrate the editor more with other third-party applications, so you can actually interact with them in real time. If I make some changes in Maya, I want to see those immediately in the editor without having to export my meshes and then re-import them in the editor. I'd like to be able to do all this in real time. That's another really cool application for the messaging system. And there's also a way to theoretically do this communication over the internet. There's some other system that I wrote, a message tunnel, which allows you to bridge the gap between different network subnets. The UDP transport itself right now, it uses multicast packets, so it can only see other endpoints that are located on the same physical network. But with a tunnel, you could extend this local network to anywhere on the internet. I can't think of any applications right now, but I'm sure some of you in the community will have some ideas for that. So where is this stuff being used, if at all? And it turns out the message bus is actually used in a number of systems already. If you go into the session frontend, for example, which is kind of the successor of what was Unreal Frontend in UE3, pretty much all of the features in here are driven by the message bus. Things like discovering your running game instances, like whenever you run some instance of the engine on your computer or elsewhere on the network, you will be able to see it in here, and you can interact with it. For example, here I currently have the Unreal console open, so you can actually send commands to it. Let's do show FPS, and if we go to the viewport, it should pop up. Didn't quite work as expected, so let me see. Did it go through?
Stats may not be enabled.
Oh, yeah. Well, you get the point. So here you can remotely interact with engine instances anywhere on the network. Same for the automation system. Whenever you run automation tests here, let's pick like a random one here. Let me see. Yeah, this one is fine. So here we use this automation system to run unit tests to verify that our code is correct. That automation system under the hood also uses the message bus to do the communication, because we're actually able to run automation remotely, which means you don't necessarily have to run these tests on your local PC, but you could actually execute them remotely on a PlayStation 4 or on an Xbox, where the same code might have completely different results. So it's important that we can do this over the network. One early, if not the very first use case for the messaging system was device discovery. Like whenever you go here to launch, we don't have any devices attached, but if you do have iPads and iPhones or Android devices or Xboxes or PS4s attached, there's going to be a list of devices here. And that discovery mechanism, like how does it find out about these devices? How does it know that they exist, and how does it deploy builds for them? That's also built on top of the messaging system. I just want to briefly show the architecture for the target device management in particular. You don't have to understand all the details because it is somewhat complicated. But if you first look at the code, you will notice that there is an architecture that seems to be a little more complicated than it needs to be, perhaps. Usually, you might wonder, why doesn't the application talk to the device directly? If I have my iPhone or my iPad attached via USB to my computer, the editor could just talk to that device directly. Why does it need to go through these layers? You can see that here we split it up into the application layer on top And then there's something called a device proxy, which is kind of like a remote representation of an actual device. There's a device service, which makes a target device available to an editor somewhere else. Then you have the actual target device itself, which represents like an actual Xbox or PlayStation 4. And then that code usually communicates with some platform SDK to send commands to the device or retrieve data from it. And then in some cases, like on iOS, we have even another layer, like the launch daemon, where it's possible to communicate with an iOS device, even if it's not connected directly to the computer, but perhaps just over the network on Wi-Fi. And when you think about all the different combinations, like all the different ways that devices can be attached or where they can be located, it gets really quite complicated, because in some cases you might want to deploy your game to an iPad that's connected to your local PC. In some cases, that same iPad might be connected to someone else's PC. Maybe you want to share the same device. If you develop for PlayStation 4, for example, you know those dev kits are really expensive. I think they're still almost $5,000. So you may not have the resources as an indie studio to buy a dev kit for everybody. You may just have one or two. And it would be nice to share that dev kit between multiple developers. We also have a use case where we want to run automation tests from our build system. So we haven't quite implemented this yet, but there will be a setup eventually where we run a farm of computers that have various mobile devices attached to it. There are so many different kinds of Android devices. We'd like to set up a farm of just Android tablets and Android phones in particular, and have our build system verify that everything is still okay. The code still runs and the content doesn't produce any errors. So there are many different ways that devices can be set up. And the cool thing about this architecture, what like first looked somewhat more complicated than it maybe has to be, turns out to be a really simple solution, because we can model all these different use cases with the exact same code. Like if you look at these 4 silos here, which are just like 4 examples of how the different layers can be spread out amongst different computers, you will see it's always the same thing: application proxy service device, application proxy service device. The communication in between is always the same as well. So we can use just one version of the code to support all these different use cases. Contrary to popular belief, I think the job of a programmer is not to write code, but to not write code.
Well, it's not my job to write code, so somebody needs to be there doing it.
Yeah, really, like my most productive days are those where I delete a lot of code from the engine.
Mine too.
Yeah.
I just don't know what I'm deleting.
Oh,
Well, you shouldn't be deleting randomly, but every line of code that doesn't exist can't have bugs. It doesn't need to be read by anyone.
Wait, I need that on a shirt. Every line of code that doesn't exist can't have bugs.
Yeah,
that
it's
is
true.
a
Our
great,
QA department's going to love that.
that is an
It doesn't need to
amazing
be
line.
maintained. It's the less code you have, the better. So I really think if like a programmer's main responsibility is to try and figure out how to not write code. It sounds a little counterintuitive, but that's really what it is. So with this setup, that's, as you can see here, it's mostly driven by the message bus. Under the hood, it really allows us to have just one implementation of the stack and use the same software stack for all these different use cases. Here's like a little overview of how deployment works in UE4. It's you don't have to understand this.
That's good, because it's not gonna.
Yeah.
It looks very complicated,
And
but
it is.
The main takeaway here is that all these lines, they would usually happen all within the same process. when the application talks to the device directly. In this case, with the layered architecture that we have, these arrows are possibly connecting different computers or different processes. But it's essentially the same thing.
In the case of something like lightmass versus or swarm,
right?
Doing distributed tasks or something
Yep.
like that.
Exactly. So let's take a look real quick. I think we still have a few minutes, huh?
Yeah, we're good on time. So yeah,
Now,
if you want to do that.
you may be wondering, with messaging, message-based architecture is highly asynchronous. You're not getting results right away. You're sending off a message. It could be a command, for example, do this. And then at some later point, the recipient will receive this message, process it, execute the command, and then perhaps it will send a response. There's some amount of time passing between all these steps, the sending, the processing, and the receiving. So this can be notoriously difficult to debug. You don't see right away what's happening like you would if everything were just function calls within the same process. So I wrote this tool called the messaging debugger, and it's still early on, which is the main reason I haven't talked about that much either. But you can activate it in the plugin settings. It's under messaging, and here's the messaging debugger. This is the second plugin down here, by the way, is the UDP transport. It's the only transport we have right now to bridge several processes. But if you enable the messaging debugger, which is turned off by default, then you can go into developer tools and fire it up. And you can actually start the tracing mechanism and see all the messages that are currently being routed within the process. In this case, the editor that we're in. And you see there are already quite a few messages going through here. Most of them are messages for locating target devices. You see there's like ping and pong. That's a very common pattern. If we run, for example, automation on our local instance here in the session front end, let me make this a little smaller. And by now it should already have, like when it populated, the available automation tests. Let me pause this here for a moment. You see a bunch of messages going through to communicate which tests are available on this local instance. And let's just run one of these real quick. Let's run a couple of these and go.
Measuring in picoseconds?
These are microseconds.
Yeah, but the US?
I'm sorry?
You have milliseconds and microseconds?
Yeah, there are milliseconds and microseconds. So you see a bunch of messages went through here to report the results. There weren't any errors in this case. There are some ways of filtering here. I still need to put a lot more work into this. This has been mostly one of my little pet peeves that I work on Epic Fridays. If you don't know what Epic Fridays are, it's like this one day of the month where we get to do whatever the hell we want.
I think you mean pet project. A pet peeve is something that drives you crazy. A pet project is something you work on the side.
That's right, a pet project.
Pet project, all right.
His pet peeve is that it's not done.
Yeah, that's it, okay.
Yeah, it's not quite done, so perhaps later this year I'll have some more time to add some more cool stuff here, like breakpoints and so on.
Yeah, is any of this going to be included experimentally in upcoming builds?
Yeah, like I said, this is already available.
Oh, okay. So
it has been in the engine for several years now.
You just have to turn on the...
Yeah, you
just have to show it, and okay.
That's right. Messaging is always enabled, at least the in-process messaging, if you want to use it across processes. Currently, we require a command line switch. It's like dash messaging on the command line for game builds. It's just a safety restriction because we still have some some instabilities in there, and I don't want to enable it just yet for everybody. It might crash, or it might cause security. It might have security concerns. So once you turn it on, you'll have that, and you can see this tool as well. I'll try to write up some tutorial, some documentation in the near future, and then I can talk about this in a little more
sure
detail.
That would be well appreciated.
Yeah. All right, so let's go back to the original use case for the GDC demo. So essentially what we do is we use the messaging system to continuously send messages from the iPad app over to the configurator, and they discover each other automatically through the publish subscribe pattern. So things just work. There's no configuration required. You don't have to enter IP addresses or anything. That example is super simple. We in fact only have a single message type, even though we perform only one action, like change the color or open the door or explode the car. We have just a single message that contains all these possibilities, and there's like an enumeration switch. So in a typical use case, you would have many different types of messages that communicate different things. We just tried to get this up and running quickly and just jammed everything into a single message. And another thing that we did, and this was somewhat overkill for the GDC demo, but it was an opportunity for me to try and test another system that I've been working on the side, which is an IPC layer built on top of the message bus. I said earlier that as a user, you don't want to deal with the details of network sockets, and as a programmer, you don't care about how things get from A to B. Well, it turns out that a lot of times that we use the messaging system, we implement the same patterns over and over again, like in that part. We're no longer dealing with sockets, but certain aspects like discovering some kind of service on the network and then starting to talk to it directly. That's kind of like always the same thing. The different use cases that I showed you that we have, they're all kind of built the same way. So again, I'm trying to simplify this code and reduce the amount of duplication, like these repetitive tasks that we have to do each time. So the reality is, while the messaging system is pretty cool, as an application developer, I don't want to deal with messages either. I don't want to deal with sockets, but I also don't want to deal with messages. Really, what I want to do is I want to execute some C++ function, and I expect it to execute it wherever it needs to execute, whether that is in the local process or in some computer remotely running over the internet or somewhere else in your office. But for me as an application developer, it's just a function call. So this is nothing new. People have done this for years in Java and in C#. .NET remoting is very popular. So I'm kind of trying to build the same thing for that. And for the GDC demo, I built something similar where maybe I can show it real quick. I think I have the file open somewhere here. So instead of sending messages, you see I'm really just making function calls on what is called an RPC client in our iPad application, and then on the configurator side, there's a corresponding RPC server.
Yeah, and then inside of the game mode itself, you can see the events that Max created, or the function calls are being read here, and then inside of that particular function call, I get the event, and then whatever data is being passed along as an argument, in this case, yaw and pitch for doing rotation.
Yep.
Wow.
And that's really all there is to it. So you see there's, here we're sending a tap, and here we're resetting the configurator. It's always the same message, fconfigurator command. We're just passing in different parameters, so it's kind of hacky, but it works just fine.
Yeah, it was flexible enough that Max was able to define it, Osmond was able to work with it, I was able to filter it, and we could get any of the multitude of configuration options, special events, and input controls to work off of that single message type.
Yeah, and then in the end, there's really a lot of code here. You can see there's some initialization where we create an endpoint to discover the configurator, and then the rest is just RPC calls that's using the message bus underneath. Similar on the configurator side, there are just blueprint functions to handle the messages that were received. So whenever, for example, there's an update in rotation, we just execute some delegate and blueprint.
Which is what I'm getting, and then whatever data that I'm being passed, I handle.
Yeah, and you may wonder, like, why do we have the same code and for the configurator side and the applications, the iPad app application side? It's actually all in the same module, and the reason is that I just put all this stuff into a plugin, and we could then compile the same plugin once for the configurator and once for the companion, and that's how we bridge the gap between the different engine versions. Yeah, and if you change it in one and it works in the other.
Yeah, I mean it was transparent enough that it was never an issue. The fact that the two were on completely different branches of the engine.
Yeah. So yeah, it's a cool way to write distributed software. People sometimes ask me, when should I be using this, and for what should I be using this versus using other mechanism or writing my own. There's not really a general answer to that. I would say currently the message bus, it still has a lot of overhead. We're trying to make it faster so you can send literally tens of thousands of messages a frame without having any big noticeable impact on performance. That's not quite there yet. But if you can afford the overhead and you like the convenience, then you can definitely use the system. And I really hope that someone out there will start using it for integrating other software that's not Unreal. Maybe some 3D editing software or texture editing software or whatever. There's a lot of opportunity for integrating other things, also hardware devices and things like that.
Oh, well, speaking of things that people commonly ask you, I have quite a few questions.
Oh, no.
Yeah, I know. This is going to be pretty interesting.
Well, when we sit and talk for 50 minutes straight without letting people ask questions, they do queue up.
Yep. We got a few in here. So let's see. So at a base level, using this messaging system, you can convert multiple input devices or multiple devices to bridge inputs. I'm thinking like a phone's gyroscope manipulating input on a computer. And actually, there's quite a few questions in here about can I use this to control your VR app from an app on a tablet, or in general, I guess it's more of a can I use this more generically and to do things like with making your own custom controllers on it as an app, etc., stuff like that too.
Mm-hmm. Yeah, in principle, that's exactly what the system was designed for. And let me bring up the other slide real quick. Where is it at? Take a look. That was not it.
I think you were on it, but it was on a blank.
So if you look at this part here on the top right, where we integrate other types of processes that are maybe not necessarily Unreal Engine 4, that's really one of the big use cases that we wanted to support. The only limitation you're going to run into right now is that the only transport layer that we have currently implemented that will bridge the two processes is UDP socket based. So as long as you are using Unreal Engine 4 to write your application, which is possible, you can write standalone Slate apps using UE4. You will get all the things that you need out of the box, but we don't currently have an implementation outside of Unreal Engine that represents the other side. So you would have to write some, you would have to write the receiving side for your application in whatever language you're using there. It could be written in Python or in C# to basically translate the UDP network packets that you receive back into the messages that you're interested in your application. That's not super convenient, and I'm totally aware of that fact. Really, what I would like to do next is to write a transport based on HTTP, for example, where you can then just use any JavaScript or Python to exchange messages in JSON format. That would open up a lot more opportunities, because now we can also more easily support applications that are not written in Unreal Engine 4, but in other frameworks or programming languages or scripting languages too. Yeah.
All right. Well, then that makes a lot of sense then. I guess this one is probably going to be more for Alan, but they want to know, can you add different cars to this project, or is it all based around the one car?
One thing I did was, conceptually, I should have done this to begin with, was make a blueprint that handled all of the non-vehicle specific behavior, and then create a child of that to do
to like spawn in the vehicle.
Yeah, because instead of having the McLaren base blueprint be the one that's placed and everything is being done on, I should have done it with a kind of, parent blueprint
like
that did all of the, here's handling all the message input, here's setting up whatever behavior, and then the car specific, like what mesh and materials are applied to the car, could have been done in a child. Okay. I didn't do that. There's no reason you couldn't do it that way. The one thing that you'd want to be careful with, and the reason I should have done it the other way, is the way I'm linking interaction points to the car and the navigator and all that stuff is by just casting it to the blueprint of type whatever, and then setting that as a variable and referring to that variable later. But because there's like 4 blueprints that all cast the car and then store the car, if I change that car blueprint to, like, if I've made a new blueprint and dropped it in, I can't just directly link them up without going through each blueprint and changing the cast.
It would break.
Whereas if I did it as a parent, I could then cast and get that it's the same class and things like that. So, yes, I could easily go into the existing car blueprint and change out the meshes, and there'd probably be a few things that would have to be fixed up to make sure that material assignments got called on the right parts and things like that. I didn't do anything that was specific to a McLaren in any way. There's just things that are specific to knowing that the mesh is this name, the material assignment is expected to be found in this location.
All right. Okay. That makes a lot of sense.
But yeah, I should have abstracted it one layer. It's the downside of having such a short deadline project. You do things to get it done.
Yeah. So this was very much so built for the one demonstration.
Yes, but I really did. The reason that like the interaction points are kind of ignorant of what's going on is because I didn't know how many or where they were going to be. Yeah. So I built it in a very kind of generalized way. I could drop in as many or as few of them as wanted. I wanted to maintain that behavior throughout. Unfortunately, we didn't have the time.
It's a lot easier to just throw in some casts as opposed
to
creating a system of memorizing.
To do something where it's truly generalized, it takes a little longer in the front end because you have false starts. You have things that you realize I didn't consider when I was laying out the framework. So now I have to retrofit things in and make sure that they cascade down correctly to children and things like that.
That makes sense. Okay, cool. How did you import the CAD data for the car, or did you just like have a model sitting around that was in FBX already?
No, that was part of our communication with McLaren, was getting the CAD data to Francois and Min. Min did most of the importing. I don't remember off the top of my head the name of the tools that he brought in, but yeah, he brought it in as mesh data after doing some cleanup. CAD data tends to include a lot of additional polys that we wouldn't normally use in an in-engine model, right? For every pipe, it has the interior faces of the inner skin of the pipe and the exterior. So Min did a lot of cleanup work as well as UVing and material assignment as part of the kind of content massaging pipeline.
How many polys is it, do you know?
It's around 15 million.
15 million polys.
Yeah.
Okay, that kind of.
That's I believe that's combined with shadow generation though. So the shadow geometry as well as the base polish for the mesh. Given that the mesh isn't in a single, it's not a single mesh. It's a little harder to just look at it and go, oh,
Yeah,
this
because
is
it's so
X
many
number.
parts that all
Exactly.
explode
It's
off. And
I don't know, something like 35, 40 individual chunks, and then there's sub pieces that are skeletal meshes.
okay, I guess that kind of leads into the next question. Can you explain a little bit how you create a good frame rate using a high poly and detailed model like this?
So there's a couple different things. One is the engine actually renders triangles very efficiently. So having a scene like this where you have a lot of triangles is okay. It's minimizing the number of draw calls, so reducing the per chunk section count, right? Rather than having, oh look, this door panel has 25 different materials that happen to be like 5 materials that have the same body paint color, 5 materials that have the same rubber, condensing that down so that everything renders optimally. That, and there's careful tuning of the number of shadow casters in the scene, and how the scene is lit.
Right, that makes a lot of sense. Just to, I guess, yeah, because a lot of the shadow rendering is going to add a ton of extra weight.
Yeah,
so why
and there
not
were
just
things
render
like
the big things?
Daniel Wright was able to help out a little bit. Right, actually, he was actually going out of the country, and the last couple of days he was able to spend some time doing the depth field ambient occlusion that gives a lot of the nice shadow geometry. Get back over to here. So, like, the fact that the car nicely shadows the tire underneath the arch of the car,
Yeah.
and also the interior shading. A lot of that is actually the depth of field, the distance field ambient occlusion
Oh wow.
that Daniel added.
Okay, so that's pretty impressive to, and so that's like the machine that we actually ended up rendering it on at GDC. Do you know anything about the hardware on that?
Well, we used the frag boxes.
Okay, so
So,
they're pretty powerful.
Yeah, we had 980s or Titans in most of them, I think. We were running it at 4K at GDC as well.
So that
So
makes
I mean,
sense.
obviously the frame rate was good at 4K. Running it in a more common desktop resolution is going to run just fine as well.
Yeah, and we have a Titan X in this machine. Not that we necessarily needed that for this resolution, but
Yeah, there's actually like a lot of the material for the cars are pretty simple. Like there's very unlike something like game content where you tend to paint dirt masks and diffuse. There's a few high resolution textures, but really not much. It's for the car itself. Like the car paint has the texture mask for, or the
is that the wireframe of
Yes.
it?
yeah, that's wireframe. Oh, come on.
That's nice. No,
What?
it's good. It's good. It's beautiful. You can make out every detail of the car.
Yeah, but there's only a texture for the metallic or the flake. There's no texture for the majority of the car. There's a lot of it is actual 3D geometry.
Oh wow.
Yeah.
That's kind of an
So,
impressive.
a matter of fact, I think even some of the McLaren logo stuff, like that's 3D.
Oh,
Right. That's not.
wow.
There's very little 2D stuff on the car, and what there is just for texture masking. Like there's actually pipes in here where there's 3D geometry for all those venting and the McLaren logo and all sorts of stuff.
Gosh.
Yeah. Wireframe in here is pretty nuts too.
Are we doing any custom occlusion culling for this?
Nope.
Oh, okay.
The engine's standard bounce-based mesh occlusion.
Oh, okay.
So there is occlusion being done.
Yeah, it's just
one of the
kind of
things
the
that we were
default.
careful with was, or one of the things that Min had to be careful with was making sure that kind of part chunks, because we originally it's each individual part of the car, right? Every wiring harness, every pipe. Min collapsed a lot of those down into single blocks, but tried to make sure that the bounds for individual blocks weren't too big. Like you didn't have a chunk of interior housing in the engine compartment, and then it also happened to have a plastic clip up in the front of the car, right? Because that would make the bounds the size of the car, and since we use the bounds to determine occlusion, it would almost never occlude. Yeah. So keeping the bounds for all of the chunks as tight as possible meant that if you're looking over here and this is behind the camera, it's probably not going to render. Or if you're looking at the front of the car and there's some big chunk that could potentially occlude, and you can see that if you open up the triangle count while you're actually in the demo, you can see that it changes as you move around the car. So there is some occlusion, but it's not, given the complexity and the number of pieces, there's not a ton of gains from occlusion.
Okay. Yeah, I guess when you're working with something that's already this complex
and dense, right?
Yeah,
it's just there's so many pieces, and they overlap and intersect, and all sorts of complexity there.
All right. Well, we're running out of time, but I'm gonna throw this last one at you here. What all from this demo is going to be available to the public specifically? Because I know that the car itself, the actual configurator isn't a public thing, but there are features and enhancements.
All the features and enhancements will make their way. I'm not sure what was in 4.11 and what's coming in 4.12. I think I'd have to ask. Like Zabir did a lot of the improved resolution for cube map captures. There's better crispness on the reflection lines and things like that. The distance field ambient occlusion. All the engine features will make their way down to release. This was all done kind of brute force right before GDC, so I imagine some of it will be in 4.12 if it's not already in 4.11.
Yeah, they were saying that it's not going to be in the first preview, and we're on to the second one. I'm not sure if it's into the second one, but there will be, as we go down, there will be more included from this into 4.12. So, yep, these features are going to be coming along. For the outro today, I'd like to say thank you both for coming along. We learned a lot. It was a really great stream. I'd like to remind everybody to join the May UE4 Jam. If you've got the time for it, it's going to be a lot of fun. Please go ahead and send me in your, PM me your registration info. That's going to be a pretty exciting one. I'm still waiting to get more details on exactly what all the new stuff is going to be. Yeah, that's it. Thank you, Shelley. Thank you, everybody. Happy Cinco de Mayo. See you guys next time.
See you.
Bye, everyone.